Solving even more trig equations, in 13.4 we're going to use substitution. Because we're reviewing the fact here that you can only solve if you have a common trig function. For example, if I gave you x plus y equals 6, you wouldn't be able to solve this because you have two variables. You'd have to somehow simplify it to one variable. Same thing is going on here. We have to have only one trig function. So we want to find all the angles that satisfy this equation, and again our angles are the traditional 0 to 360. But we can't have cosine and sine in this problem, so we must make a substitution for either cosine or sine. But once again, going back to chapter 12, most of you are going to go, oh yeah, cosine squared, I can make a substitution. Cosine squared, I can substitute 1 minus sine squared. And look, now I have only sine in my equation, and I can solve. So the first thing I'm going to do is I'm going to set this equal to 0, just like I would do any equation that has a squared in it. Well, I like all my squares to be positive, so I'm going to take this sine squared and move it to the other side. And to keep setting equal to 0, I'll move everybody from the left side over to the right side. So that would give me 0 equals sine squared x minus sine x. Because these ones are going to cancel each other out. Now I'm lucky, I can factor this. No need to use the quadratic formula here. How can I factor it? By greatest common factor. There, I'm going to pull a sine x out. Now we're going to set each factor equal to 0. Where does the sine wave equal 0? And where does sine x minus 1 equal 0? Okay, I got to do a little more solving there. Alright, so that's what I get down to. Now, I could use my unit circle, but I'm going to use my waves. I know this is what a sine wave looks like. And they're asking me, where does my sine wave hit 0? It hits 0 in 3 places. So my answers would be 0, 180, and 360. But I'm going to end up rejecting 360 because my problem up here said I go up to but not including 360. Alright, and then the other half says, well, wherever my sine wave hits 1 is also an answer. And my sine wave hits 1 at 90. So I have 3 answers to this problem: 0, 180, and 90. Okay, not bad. Now likewise, I could have done this on my calculator. I could have gotten my graphing calculator out, and I actually could have graphed each wave. So this was cosine squared x plus sine x equals 1. So that's what I did up here. In purple, this is the line 1. And this red line represents the cosine squared x plus sine x. I graphed the two lines, and then I figured out where they crossed. And they crossed with the same answers I got: 0, 90, 180, and it's showing 360, but we know we end up rejecting that one. So once again, you can check these on your calculator, but you have to show all work to get credit. try one more. Okay, I've got two trig functions that aren't the same, so I'm going to make a substitution. And I'm going to make the substitution every time I see a secant. I'm going to put in 1 over cosine x. I'm going to cross multiply to solve this. Cosine squared x equals 1. Since I see is squared, I'm going to set equal to 0. And I'm going to have to factor. This factor is a difference of two perfect squares. So it's cosine x minus 1, and it's cosine x plus 1. Set each factor equal to 0 and solve away. Alright, and I'll solve this side now. Set this equal to 0, solve away. Alright, so once again, I'm going to use my wave here. I don't want to use my unit circle. This is asking, where does my cosine wave hit 1? Alright, well, if I make a rough drawing of my cosine wave, cosine wave equals 1. It equals 1 here at 0 and here at 360. But once again, we're going to reject 360 because my problem says I can go up to but not including 360. All right, and the next one says, where does my cosine wave hit a negative 1? My cosine wave hits a negative 1 right here at 180. Oh, so there's only two answers to this problem. 0 and 180. And if I wanted to, I could graph these. So once again, I could take out my graphing calculator and I could graph the cosine wave, which I did here in red. And I can graph also my secant wave, which I did here in purple. And I can see they do indeed cross at 0, 180, and 360, but we reject 360.